So, good morning, everybody. So, how are you, everybody? How was your test one?
Definitely got to practice a little bit more.
Okay. How did you do in the test one? Hopefully, you will see your grade next week. Test one grade. Okay. So today is September 28. So let us see our schedule first. So by the way, I have some programs, complete programs like singly linked list implementation, examples, C++, with header files and without header files. So uh, you can get this program from my Reddit account and this. Okay, and let us see. So I have extended the assignment 3, right? When that is due. Assignment 3. Assignment 3 will be due on September 30th. So day after tomorrow. So please work on the assignment 3, and as much as you can do, please do it yourself. And hopefully I will drop one lowest assignment grade. So even if you do partially whatever you do, please complete it, okay? And then after the due date, I will discuss the assignment. What else? So according to our schedule, so this week we are in week 6. Oh no, we are here. We are in week 7. So we will discuss tax. So it was supposed to start last week, but I could not start. So maybe, but as I discussed earlier, when you discuss linked list, stack, and QE, stack is a last in first out type data structure, right? LIFO, it is called LIFO. That means last in first out type data structure. For instance, in our daily life we use stack. So when we clean, wash and clean our plates, and we put one above another one. So the last plate we clean, we usually put on the top, and we use that first. So in a daily life, that is, we use stack. So in all programming languages, modern programming languages have stack, built-in stack in the library file, in its library file, like C++ has a stack in its library file. Maybe it is called only stack. And then Java and C#, almost all languages have stack, built-in stack. But actually, in this chapter, we will see some use and usefulness of stack and how stack is mainly used in computer programming. So mainly in executing an instruction or executing an expression, like mathematical expression. In order to execute a mathematical expression, stack is widely used in computer program. So we'll see that soon. And another use of stack is for reverse, like string reverse. So a stack is called last in first out. That means a stack has one side closed and only one side open. So everything you insert into a stack, that is called push. And if anything you take out from a stack, that is called pop operation. There is also another operation in stack we call peek. Peek operation means getting the just getting the top element but not removing the top element. Since one side of a stack is closed, so there is no way that you can, since the black side is closed over here. So there is no way that you can insert or remove an item from this block side. So only this side is open. Okay. So there is, for instance, think about a building that has only one entrance and there is no exit. So the only one door. Okay, that door is used for dual mode, for entrance and exit. Okay. So the simple operation of a stack is that, for instance, if you have a string NAT, so we know that in our natural English language, right, and also in programming languages, we start reading from left to right. Whatever character we get first, like N over here, and we get that, and then we start reading or counting that, starting with that. So NAT. But there are some languages like Arabic and then maybe Urdu and Farsi, Farsi languages. There are some languages they start from different order. They start from right, reading from right to left, like Arabic language. And in some languages, there are some languages that is read from top to bottom, or in mixed order, that's English or like Japanese, Chinese or Japanese languages. Okay, but those are maybe unfamiliar to us, those languages, right? But the most familiar language is everybody to us is English, right? English is our most familiar language. So programming languages works like same order from left to right. So it's the input, INPUT. Similarly, NAT. So then in a stack, when you put these characters, you will get N first and then put N. And then you will get A, so then you will put A on top. And then T, you will receive T and then you put T first. But when you do pop operation, for instance, you take input, you take out elements from this stack, then you will get only T first, because you cannot get A until you take out T. So then you will get T first, okay? And then you will get A, and then you will get N. So then pop operation, it comes from the top. So then you will get TAN. If you do not put this in another stack, then you will get TAN. Okay, so that is a simple operation. Okay. So as I said that C++ library file, standard library has stack. It has stack header file. So the header file has stack main stack operation. What is the main stack operation? To check whether the stack is empty. If there is no element in it, the stack is empty. To do the peek operation, that means to get only the top element but do not remove it. That is called peek operation. And another thing is that called pop operation, to get push pop operation, they remove the top element. And another operation is called push operation, to insert an element. So here we will see an example of using a stack. Here's a called stack application, how to use stack in program compiling, right? When you write a program, right? Compiler works instantly to check your program whether the instruction is complete or there is no bug in, there is no syntax error in it. So any syntax error are instantly checked in most of the compilers right now. So how do that is checked? So one thing is called, it checks balance operation. It's called balance operation. Balance of what? Balance of using parentheses, curly braces, square brackets. Okay, and some other operators. For instance, we know that some operators is called binary operators. They take two operands, right? And there are some unary operators. They take only one operand. So, for instance, here this is unary operator, and but this is a binary operator. So like this is a binary operator. It takes two operand, one's the left side and the right side. Like parentheses, whenever we see an opening parenthesis, we expect a closing parenthesis. So as many number of opening parentheses we have over here, for instance, 1, 2 opening parentheses, and there should have, so actually the number, how many, if you see as many, 2 over here, 1, 2, and 3, okay. So we see that there are 1, 2, and 3 opening parentheses in this expression. So we should have 3, not more than 3 closing parentheses. And not only 3 will not work, we should have also, for instance, there will be match. So you see that this parenthesis, this match with this one, and for this another operator after this operator. So here this parenthesis match with this with that one, and this parenthesis match with this one. Okay, and then outer parentheses that match on this leftmost parenthesis. So when you write a program, the compiler compiles the program, every statement, and check everything is balanced. For instance, the operator, all unary operators are balanced, all binary operators are balanced, all parentheses are balanced. Okay. So if there is something unbalanced, then you will see that compiler shows syntax error. For instance, when you write some program, if you skip one parenthesis intentionally, either opening or closing, for instance, this operation, you will see that at that point it will show you a syntax error. So how that works in a programming language? So that is, well, that works with the use of stack. So internally, stack operation happens internally. We do not see how it works, but externally we can realize. For instance, whenever it gives us an error message, we realize that there is something wrong. So let us see this with some examples. Okay. So let us start with this expression. So it is put in double quote. We don't need to put double quote inside double quote, but it gives that only we are considering the things inside the string inside double quote. So this is a string, right? So as a string, we know that a string is inserted in a program as a within double quotes. This is how they put in double quote. But for now, let's forget about the double quote. So if we insert a double quote, so this string in our like this is a Boolean method, is balance method. It takes a string. Okay, it takes a string and it returns a Boolean value, either true or false value. So the true and false value. So it checks, and based on what? Based on the number of parentheses. Based on the matching of parentheses. So at this point, this method will check only parentheses. It will not check curly braces. It will not check square bracket. Okay. For instance, only curly braces, only parentheses you will check. So this is why two characters, left character, left parenthesis and right parenthesis, we are dealing with in this function. Nothing else. Okay. So curly braces are checked with something else different. So here it checks if there are balance or all balance statement in every places. For instance, here it will check, for instance, it will get the expression, whatever expression is given as an input to this method. Okay, and it will get every single character from the expression. So in the expression, when it finds a left if next character, so next character, it gets next any next character, it's a put the character. Whenever it gets a left parenthesis, this one, and then what it will do, it will put the next character to our stack. So this is stack is used, built-in stack is used. Okay, and it types is, so you see that within angle bracket character, that means this stack is only restricted with character type. With angle bracket, that means it is restricted with character type, and stack name is called store. So then store dot is push operation. We have push operation later on other side. Okay, not here. Yeah. So and the next character is that means the parenthesis. If only is parenthesis, that left parenthesis that is put in stack. And then else if the next character is right parenthesis. If it is right parenthesis and the store is not empty, that is stack is not empty, then what it will do, it will pop. See that pop operation, it does not take any argument. It just guessed, it just gate the top element, top character. So since our store is a character type stack, so every time it will get a single character. Okay. And else if the next character is right parenthesis and the store is empty. Okay. Then initially it was boolean return type. So initially it was set false. Okay. So return false. It was assume the return false. But if this condition matches, this condition is matched, so then it will make fail equal to true, and then it will return store dot empty. That means it is literal either true or false. Okay, we know that an empty method, that means it checks whether this store stack is empty or not. If it is empty, then it is returned true. Okay. And If it is not empty, then it's return false. And so then return will be the combination of these and Boolean AND operation. Okay, and that not failed. Not failed, that means if failed equal to true, then not failed equal to false. And if failed equal to false, then not true equal to not false, that means true. So in order to get this return true, it both need to be true. Store need to be empty and this part need to be true. Okay. So here is this last condition. You see that it checks. Okay. So if that is condition over here, if next character is right parenthesis, but store is empty. Store will come with that. So that means if there is nothing to match, okay, for instance, for every right character, we should see a matching left parenthesis, right? So, but if that does not match, then it will say fail equal to true. That means it will be fail. Then it will, if this fail true equal to false, then it will not result a true value. It will result a false value. That means every right parenthesis need to be matched. So let us see that with an example here, so it will be clear. So yeah, in this expression, for instance, if we see this expression, right, how do we check that this is plus operator? We just in visually in mathematics and algebra, we are familiar with this type of expression, right? So whatever we see that, we know that we need to do the operation for the inner parenthesis, inner group first. So this one, and also we will do this one, a plus b, this one, right? And then after that, this part will be multiplied by this part, resultant value, and after that y will be multiplied with that resultant value, and after that resultant value will be added with x, and it is worked that way, right? So if you put this kind of operation in this method, then it will it will return a true value. Okay. Otherwise, for instance, this one, okay, so if we get this one, so it will give us a false value, because sorry, we see that this one is matches over here, so this one will be executed first, that one will be multiplied by y, and this one will be multiplied. Okay, this one will be multiplied, and then we will have one parenthesis on the right side, but in the left side still there are two parentheses. There is a mismatch, so it will result a false. Okay, so how that does work? So here it will see that, let us start with simple examples. So he said it has two sets of two opening parentheses and two closing parentheses, but this will match because now we know that outside will match with the outside one and inside one will match with inside one, right? And then this will match, so that means inside will match, and then this outside will match, and this right side this will match, and also this will match. So here this part will match and this part will match. Okay, so what is the trick over here? How does it work? It works in a way that as soon as it gets an opening curly brace, so opening parenthesis, the next So we are not considering any other characters like A, B, C, D, X, Y, Z over here. Okay, we are considering only opening and closing parentheses. So the next character, next opening or closing parenthesis will be whenever it gets opening left, and then that next one will be right. And then as soon as this match, so this will get out from the stack. So that means the first one, it will come to the stack, this one. And the second one, it will come to the stack, this one. And then as soon as, for instance, whenever it gets, there is an existing, so whenever it matches, whenever, so if there is the trick is, formula is like this. Whenever it has left, it gets a left parenthesis, it will put in stack. And whenever it gets a left parenthesis, it will put stack. And whenever it gets a right parenthesis, then it will match this right parenthesis with the top element existing left parenthesis, and it will get it out. And then when there is a match, this maybe it is vanishing. Okay, and then after this is vanished, then we will have this one in the stack. And whenever it gets this one, so then it will match this one with this one, and then there's a mess, and then all of these are vanished. So then the stack will be empty. Right? So this way, if you remember that way, so you'll remember that. So it gets left parenthesis, it will okay. Then it gets right left parenthesis, it will put on the top. And then when it gets right, then this will be matched, and then both will be gone. And then whenever it finds another right parenthesis, then this right parenthesis will match with this, and everything will be gone. So at this point, stack is empty. And whenever it gets left parenthesis, it's okay, it will put in stack. Whenever it gets right parenthesis, then it will put in the, it will get the left parenthesis and will match and then get it out. So in that case, our stack is empty and there is no more. Stack is empty and there is no more left or right parenthesis in the character set. So that will work. For instance, it gets this one, third one, it will put in stack, then it gets this one, this will put in stack. Whenever it gets this one, it will match and then it will vanish. And then whenever it gets this one, it will put in stack. And whenever it gets this one, it will match and then this will vanish. And then still it has this one. And then whenever it gets this one, then it will match with the last one with this first one, and they will finish up. And that will work. And then, so in that case, there is no left parenthesis in the stack. Stack is empty, and there is no either left parenthesis or more right parenthesis in the string. So this will be your test. Okay, so this one, how that whatever I discussed here is given with this stack. So for instance, initially stack is empty. Whenever we get this character, this is will be put in here. Whenever we get this character, then this will be put here. And whenever we get this one, okay, so then this one will match with this one, and they will vanish, and stack will carry only this one. So here is this one only stack. And then whenever it gets this one, it will put over here. And whenever it gets this one, so this one will be matched with this one, and they will vanish. And stack will contain only this one. And whenever it gets this one, this one and this one will be. Whenever it gets this one will be vanished. And at this point, stack will contain only this one. So this one, when it gets this one, so that will match, and stack will be empty. So initial stack is empty, and then final stack is empty. So there is So according to this, if store is empty, stack is empty and not failed, you see that when it will be failed, if the next character, if there is stack is empty but there is remaining right parenthesis. So only so actually that whenever as soon as it get left parenthesis, it put in the stack. So one thing is that it never put the right parenthesis in the stack. It never put the right parenthesis in the stack. It always put the left parenthesis on the stack, and whenever it encounters the right parenthesis, it matches the right parenthesis with the top most left parenthesis in the stack, and they make a pair, and they throw that pair. Okay, that means the operation is done, that complete that operation. So whenever we put in numbers, now numbers, we will see that for numbers there are two stack maintains, one for the numbers, another for the characters. Characters over here, that means operators, plus, minus, division, multiplication, these are the operators. And maybe the right character. So as we see, the right character is right parenthesis never put in the stack. Okay, so let us see an expression how this is executed in stack. So this will be a test question. Okay, so in the next test you will get a question like this. So you will be given an expression like this. You have to show the stack state. Okay, so we know that everybody knows here how to do this kind of operation, arithmetic operation. Okay, with a paper and pencil, but your task will be showing the stack state for this kind of operation. So as we know manually, we know that if we ask you to write this kind, to execute this, evaluate this kind of expression, you will manually do this. Like for instance, you will do the left parenthesis, this operation in a left pair. So you will get 9 plus 6, 15. So you'll put 15 over here and then divide by 2, and then in the first iteration you will get this. And the second iteration, what you will do the parenthesis first, right? So you will do the parenthesis, this group first. So 15 divided by 3 equal to 5, and then you will leave the rest as is. And the second one, then third iteration, you will give emphasis on this part. So then you will execute this one, 6 minus 4 equal to 2. And finally, there is only one group, even it is put in parentheses or not in a parenthesis. So you have only one group, then you will execute this, then you will get 5 times 2, 10. So this is executed in mathematics, in algebra. Okay, at this point, does anyone has any question? Is everybody okay? Do you have any question? Okay, from our next lecture, okay, and we will take attendance, oral attendance. I will call your name Okay, and then whoever respond will get point. You know that maybe we have a 5% point for the attendance, right? Let us see.
Yes, sir.
Let us see. Okay, so we have 5% point for class attendance and active participation. So sometime I noticed that after the class is over, still some students are online. That means they did not know that when the class is over. Okay, that means some of you maybe did not, some of them did not give attention to the class. Maybe this they just log in and they went away. So I don't like to do that way. So let me do an attendance today. Let me see. Okay. So here today is September 28. How do you take attendance? Hide. Yeah, could you please tell me your name, who are present?
Can you hear me, Professor?
Myers-Berry.
Sebastian Oates.
Can you please tell me your name? Let me take attendance today. Who are present?
Myers-Berry.
So let us go from the top. Please, from the top, let me tell you name. Anne, Jason is here. Matthew Ashford, Daniel, Myers.
Here.
Myers is here.
Yes, sir.
Okay, and Antonio,
Here.
you're here.
Yep.
The next time I will see your face. Okay, Jasmine, Tatum, Elisa, Tyler, Ernest, Angel,
Here.
Jadon, Cody, Isa, right? Isaiah. Isaiah. No. So if I do mistake in spelling your name, pronouncing, please correct me, okay? And Jamie.
Here.
Savvy. Jamie.
Here. I'm right here.
Okay. Savvy. Loyal. Dave.
Here.
Here.
Oh, well is here.
Karen. Mikhail. Jess. James. Brandon. Noah. Alan. Kenia. Jimmy.
Here.
Jimmy.
Yep, Jimmy's there.
Thank you. Lydia.
Here.
Thank you. Jesus. Cameron. Sebastian.
I'm right here.
Sebastian.
Can you hear me? Can you hear me?
Yeah. What is your name, please?
Sebastian.
Sebastian. Sebastian. Okay. Alice.
James is here, by the way. Hello.
Who is James?
23, line 23.
23. Okay. That's good.
Hey,
Okay.
Professor.
Yes.
I'm sorry. Jason is here too. My computer or internet went out right as
What
you
is the row
started.
number? Please tell me the row number.
Number one. Or number two. I'm sorry. Number two.
No,
Thank
you're
you.
okay. Yeah, I got it. This one. And Alice, Justin, Daniel, Andrew. If
Here.
someone is left,
Andrew's
please
here.
tell me your row number. That's fine.
Nicholas, I'm here.
Nicholas here. Okay, Jessica. Okay. Let's see. 1, 2, 3, 4, 5, 6, 6, 10, 11, 12, 13, 14.
Alec Walsh is here.
What is the row number, please? Row number. Tell me the row number.
I don't know what his number is.
Row number. You see that for each Excel, there is a row number on the leftmost column.
It's row 33.
33, right? Okay. Sabi.
Yes, that's right.
A lot of people are in the chat. I don't know if you can see that.
I don't like to spend too much time for checking attendance. Okay, so as soon as you are fair, I like to be fair. Okay, so that I did not expect that some student will just join in the lecture, but they will go away. I did not think that way. Okay, so I was surprised. Hey, what happened? The lecture was over, but still some people who are still online. Then I thought, no, I need to take an attendance. Otherwise, I was fine because I was taking the what is called attendance. What did we get last time? Attendance. Okay, so let's go back. Okay, so far is good, right? Everybody, nothing new, right? But in computer operation, how a stack is used internally, we do not see these operations, okay? But internally it happens. How it happens? For instance, let us see how this statement is executed in computer memory, and this will be your test question, okay? You will get some question like this in your assignments and test for the next test, okay? So please give attention. So here we have two methods. For instance, one method is checking the parentheses, messing up parentheses, okay? So as we see that when that expression is given to the compiler will check the parentheses. But in one phase, it will check the parentheses, right? If that is like that method, it will be executed. For instance, this method is balance method will be executed. If the is balance method returns true, then it will come to execute this statement, right? If that is false, then your compiler will show an error message. Then it will not be starting execution, right? So we need to check, we need to fix the number or occurrences of parentheses, right? First, right? That will be checked first. For instance, let us assume that is true, and as we see that this is balanced. So then what will happen? Then it will maintain two stacks, one for number, another for operations. Operations stack will use only the operators. What are the operators? Plus, minus, division, multiplication. Okay. For instance, for now we have four kinds of operators, right? Plus, minus, division, multiplication. And then it will start from stacking the numbers in the number stack. So then 6 will go all the way, it will come first, it will go all the way down. And then it will get plus sign. And whenever there is an operator, okay, then it will put on the operator stack, then it will get plus sign. Okay, and the 9, the operator, whenever it gets a plus operator, and then it will get then the plus operator, and it will put the plus operator, and then it gets a 9, so 9 will put, and as soon as I see, you see there is a match, a parenthesis. So then the plus operator will pick the top 2 elements from the stack, from the number stack. Okay, then it will do the operation. So the 9 will go on the right side of plus, and then 6 will go to the left side of plus. Okay, and then it will do 6 plus 9, then it will come up with 15. Then instead of 9 and 6, those will be pulled from stack. So then 15 will be put in the stack. And so that plus is already gone, right? So when our plus operation is done, then plus will be gone. So then at this time, after this operation, stack will hold 15, and then the number stack will hold 15, and then operation stack will hold nothing. Do you understand this phase? One thing you should remember that number first one, top one, will go to the right side of this operator. Because for some operations, in this case for plus operation, it is not a matter. But for other operations like my division and subtraction, this is a matter. So order is matter, right? So you cannot put this 9 on the left side and 6 on the right side. The first one will go right side because the right of the plus operator, it takes 2 operate, one in the right side and another in the left side. So after this, your operation stack is empty, but number stack is 15. Okay, so the number stack is 15, that put is 15, and then it gets plus, and then its plus will be put, and whenever there is a parenthesis match, then this plus will pop the top two elements, top 2 numbers from the number stack, and the first one will go the right side, and the second one will go the left side of this operator, and then 15 minus 3, it is 5. Remember that it is not 3 divided by 15. Don't be confused, because the first one will go right side and the second one will go left side. So that this operation at this space, the number stack will hold 5 only, and then operation stack is empty. Now, so stack already contains 5, right? And it will go for this operand, and it will put over here in the number operator, and then put in the number, and then it will get 6, then 6 will put over here, and the number minus sign will put over here, and then 4 will go over here. So then at this phase, it will be doing the subtraction operation, and then 4 will go right side and 6 will go left side, then it will give 2. and then value is 5 already exists, and 4 and 6 will be out instead of 4 and 6. And instead of this operation, it will result 2. So at this point, I have a question to you, but I am asking, do you have any question at this point? Or does anyone has any question at this point?
No, I don't have a question.
Okay, I expect a question. If someone has a question, then if you don't have a question, but I say that I have a question, and I'm giving a second. Let me see if anyone has a question. Is there anyone that has a question at this point? Everybody is good. So Loyal, you raised your hand. Do you have any question? Loyal, you raised your hand. Okay, so my question is that you see that before it encounters the subtraction operator, it first encountered the multiplication operator. That multiplication it got this multiplication, but why that multiplication operator has not executed? So whenever at this point, so it got so here, why this multiplication operator is not executed? Why it was waiting for this subtraction operator? You know, my question is that after this, at this space stack was empty, right? This one was empty. So then after that, at this point 5 was here, and then 6, whenever it encounters 6, before it encounters 6, it encountered this multiplication sign. So my question is that when it encountered this multiplication sign, why it did not multiply 5 times 6 or something? Why it was not executed? Do you have answer? Because we see that it will match, it will the execution will happen pair by pair upon the mass of square the parentheses. So here at this place, when it encounters this multiplication, still it has this one left. This one in this left parenthesis in the query, in the stack, in the parenthesis stack, but it was waiting for a matching closing parenthesis. So here at this space, it encounters opening parenthesis. It did not encounter closing parenthesis. Okay. If you would encounter in a closing parenthesis, then for instance here, if there is a closing parenthesis after 6, instead of this opening after 6, if there is a closing parenthesis, then it would do that operation for matching the closing parenthesis, opening parenthesis with this closing parenthesis. Since it did not, it encountered and after this it encountered an opening parenthesis, it is waiting for another occurrence of closing parenthesis. Okay, this is why this star has not executed here at this point. Do you understand?
Cups of buttermilk. We're also going to add.
Sorry? Okay, so after that it is straightforward, and you should understand this. This is simple. Then 5 times 2, and then it is times, and then times will pick up, and then there is a matching. At this point, what will be the matching? At this point, matching is from with this opening brace opening parenthesis with this closing parenthesis. Whenever there is a match, it will be executed. Okay. And okay, this is your homework I'm giving you. So the program is written over here. So you will just copy. So the basic calculator program, you will copy this code and in your complete program, and you will copy and run it and execute it and test with some program. Okay, the program is written over here. Okay, so the stack program evaluates stack stops. It is complete program. This program is written over here. Okay, so main, and then take this one. So okay, so please get this program and okay, where to get the push and pop. So here in this program they use stack, built-in stack. So that built-in stack is giving you the push and pop operation, giving you the push and pop operation. So you don't need to write code for push and pop since it is using this built-in stack class. Okay, so practice this program. And if you get stuck with this one, please let me know, okay? And then the next one, there is example of implementing stack class. Okay, implementing stack class. Stack class can be implemented in 2 ways using array type. So this is the first program, it has array version. Okay, please copy and paste and then understand this program. And the second one is the implementation with with the second one with the linked list version, linked list implementation of stack using linked list type code. Okay, the code are already over here. Okay, so just copy paste and get this and try to run. So you see that there are some okay, there is a namespace and the namespace is using the namespace declare over here. So just copy and paste this code. Okay, and then let me spend a few more minutes. There is a well-known term in mathematics and data structure, especially in related to structure. It is called Polish prefix notation. Polish notation is by default it is prefix, and there is also another called is postfix, Polish prefix, and there is called postfix. Okay, and okay, there's prefix notation and postfix notation. Prefix and postfix, this notation mainly is prefix notation. These are used in some languages, like for instance, if you had name Scala, a programming language that uses prefix notation. And if you know some other programming languages like scam, or what is that in mighty builder. So those languages, especially the languages that use is called scripting languages. Some of the languages they use prefix and postfix notation for math for expression, but in general, we in algebra we use infix notation, right? For instance, this is the notation we use. This is the expression we use in our daily life in mathematics and in most of the programming languages. Okay, so that is 7 is parenthesis 7 plus 3 times 5. The 3 times 5 will be executed first, and then it is another enclosed in square bracket parenthesis, So then this will be executed first, and after that is execution, it will be this will be executed later. So this expression is written in postfix version like this. Okay, now not only this, for instance, here including this one. Postfix version is called Polish notation. The operators are written later. Okay. And the operands are written first. So since there are two operands for each of these operators, so there will be. So here, this will be mass, so 3 times 5, so 3 times 5. This will be executed. And after that, it has 3 times 5, 15, and then 7 plus 15. This operator is equals 15. 7 plus 15 is equal to 32, right? Or 22. Then 22, then it will be 22 minus 4. That will be, result will be 18. Result will be. Okay, so this is in postfix notation, and this is in prefix notation. So another call is prefix notation. That means prefix notation operators are written first. Postfix notations operators are written later. Not all the way later. You see that there is a match. So instead of brackets, so the matching it works as an internal parenthesis. Okay. So the well-known is called is a prefix. So we use infix notation. In mathematics, we use infix notation. So there is this is the illustration how to convert an infix notation to a prefix, or a prefix to a postfix, or postfix to prefix. There are some examples. So for instance, if you are given an expression like this, okay, so this is the postfix version is like this. Okay, so please read this part of this chapter. Okay, and there are some examples over here in our last lecture. Next lecture, we will go through this, and with some examples, we will go through. So there are some examples, illustration. Please read this illustration, okay? And then I will spend some time next lecture to give you an overview how does it work. But this will be from in your test question, okay? So and then this will see that how does an evaluation it works. So for actually internally stack work like this way. For instance, if you are given this operation in a stack, okay, so then 5 and then 5 will go in the here, and then 3 will go here, and then 2 will go here, and as soon as it encounters an operator, binary operator, then it will pick up the top 2. It will pick up the top 2, the binary operator, it takes 2 operand, right? So then top 2, then you will top 2, then 6, then this will be gone, and then 6 will be over here. So in stack I have in 5. So stack grows and sink, grows and sink. So, and then as soon as you encounter plus, then this 6 and 5 will be 11, and after this plus operator it is done, and then 4 will be in the stack. Okay, so 11 is already 11 over here, and then 4 will be in stack. So as soon as it gets minus, then what will happen? Then 4 will go right side of minus, and then 11 will left side of minus. So that means 11 minus 4 equal to 7. You get 7, and this up to this part is done, and then it encounters 5, and then when it encounters 5, 7, and then 5 will go right side and 7 will go left side of plus, so then it gets 12, and it's done. Does anyone has any question for this one? Okay, please practice this. Okay, practice this. So this is straightforward. So actually a stack is used like this way. So simple algorithms are given over here. Pseudocode is given over here. Pseudocode, okay. And this operation is converting the infix expression. Infix means that operators are written within the operand. We usually write our expression like this way, but prefix and postfix there are special cases. So I want to give example about postfix notation. This is the postfix notation. So this is the postfix notation. Please read this at home, okay, and then how it works. And if you don't understand, then I will go through this, and then you will get a test question. Any of the two kinds, like you will get test question like this. Either this one is easy, this one is simple. This one is simple. You should learn this in a few minutes, but this one is a little bit complicated. Practice this one. Surely you will get test question from this. Okay. Does anyone has any question?
No, I don't.
So please read the book, okay? And you need to read the book. Unless you read the book, you will not understand. You will not remember everything. Thank you so much, and you have a good day.